Alright, so notes part 3. Here we're talking about domain of the function. And I think you know what domain is. It's all the acceptable values of x that can go into the function. So we've talked about some real world examples. And, well, okay, so let me write something. So first it was like you looked at a function and you looked at the domain and it was all the possible x values, and if you're looking at the graph it's pretty straightforward. So for example here the domain would be all real numbers, and if we had a situation like this, let's say that's at 2, we would say, because this is at 2, the domain, we'd say x can be greater than or equal to 2. Okay, so if we're given the graph it's not that challenging. If we're just given the equation and you don't know what the graph looks like, it can be more challenging. But the bottom line is there are two things to look out for. And that is, you don't want to divide by 0. So we can put a red cross through that. So we don't want to divide by 0. And we don't want to take the square root, and technically no even root, so 4th root or 6th root of a negative number. So that's what we're looking for in these equations, to find values of x that are not acceptable. Otherwise, the values will be acceptable. So here we have, there's a fraction, and x is in the denominator, so what we're looking for is this cannot be 0. So we can say 3x minus 6 cannot equal 0, in which case 3x cannot equal 6, in which case x cannot equal 2. So all values of x except 2 are acceptable. If we were graphing that on a number line, we'd have 2, and it would be an open circle, and everything to the left and to the right would be shaded. But for this assignment, or this week, writing the domain like this is fine. Over here we have another fraction, and so this cannot equal 0. So x squared plus x minus 6 cannot equal 0, in which case x plus 3 times x minus 2 cannot equal 0, in which case x cannot equal negative 3, and x cannot equal 2. So if we were looking at that on a number line, we'd have negative 3, 0, 2, and there would be open circles, and every other value would be acceptable. So here we have a square root, and this cannot be negative. It can be 0. So x equals 5 is an acceptable value. But the way we can say that mathematically is x minus 5 cannot be negative, meaning it has to be greater than or equal to 0. So we can say x has to be greater than or equal to 5. So that's our domain. If we were looking at that on a number line, we would have 5, a closed circle, and all of these values would be acceptable. And you can see if you take any of those values, such as 6 or 7 or 1,000, and plug them in, we are not taking the square root of a negative. So again, here, the square root must be greater than or equal to 0, in which case x squared must be greater than or equal to negative 1. And so if you're here and you're like, well, how do I solve this? Do I take the square root of both sides? What's going on with the square root of a negative? Let's take a look, because x squared, when we take any number, such as negative 2.5, and we square it, we're going to get a positive value, and I think that's 6.25, but it's positive is what we're interested in. So this is always positive. A positive number is always greater than negative 1, so the domain is all real numbers because there are no unacceptable values. Unacceptable values, meaning there's nothing that you can plug in for x that will make that a negative. All right, and let's take a look at this. So I think this is not factorable. So we're looking at this, and again, this cannot equal 0. So we have x squared plus 2x plus 1 cannot equal 0. So if we try to factor this, oh, maybe this does work. X plus 1 times x plus 1, that's actually looking good as a factorable thing. So what that means is that x may not equal negative 1. And we get the same thing from the other factor. X may not equal negative 1. And so let's see, if we plug in a negative 1 here, we end up with 1 minus 2 plus 1, which would give us 0. And so that's no bueno. So this right here we can call the domain. So all values of x except negative 1 would be the domain. And lastly, so here we have, this is a cubic function. Graph would look something like that. But the bottom line is that there's no variable in denominator, and there's no square root, and I'm going to be more precise and say no even root. So that's like square root, fourth root, sixth root. So we're not going to get unacceptable values from here, and we're not going to get unacceptable values from here. Therefore, the domain is all real numbers. And that's true basically for any polynomial function. Although this is sort of easier to remember, because if you're remembering this, then you have to know the sort of technical definition of polynomial function. Okay, so in summary, the bottom line is, when you have the equation and you're finding the domain, you're looking for what values of x would make it dividing by 0 or taking the square root of a negative, and those values are unacceptable. Thanks.